Point discontinuity is a hole in the graph, literally a hole in a graph of a function. I mean, there's ways that graphs that aren't functions can still have holes in them, but we're only going to focus on the functions, right? So our process is going to be to factor the numerator and the denominator cancel any like factors right? So cancel any like factors. There might be more than one set of common factors. Graph the original function and the simplified function. Now, the short thing that I could say at this point would be and compare, but it doesn't really tell the whole story. Right? The original function is going to have an instance where it's undefined. Right? Sorry, my penmanship went like kind of haywire over here. Let me just fix that. All right. Original function will have an undefined value of x that is not undefined. This is the mother of all run-on sentences, but just bear with me, for the simplified function. All right, so you'll notice I didn't say synthetic division anywhere. That's something. I mean, unless you like synthetic division, in which case, sorry. But you saw that problem. Saw that problem earlier. I got to imagine most people are not sad to see it go, at least for a little while. All right. So we factor the numerator and the denominator. Numerator's already, there's nothing to factor. The denominator, difference of perfect squares, x minus 2x plus 2. We're going to cancel any like factors. Right. I am going to take note, though, that f of x is undefined. I'm going to look right here. I see two factors in my denominator. I'm going to take note that it's undefined when x is equal to 2 or x is equal to negative 2. I mean, you just look at those two factors. If I put a 2 in here, it makes that first factor 0. If I put a negative 2 here, it makes that second factor equal to 0. All right, so then we simplify by canceling the x minus 2's, and that's going to give us a new function. All right, we're going to call that y equals instead of f of x equals, because it's different enough that we can't call it the same thing. All right, so it simplifies down to just a 1 over x plus 2. All right, and that's because these two factors would cancel to give you, anything divided by itself is equal to 1. All right. So now this function is only undefined when x is equal to -2. Based off that denominator. All right, so what we're going to do is we're going to graph them simultaneously. F of x is equal to your original function, x minus 2 over x squared plus, x squared minus 4. And then I'm going to graph y equals 1 over x plus 2. Now you see, if I turn them on and off one at a time, they both look essentially the same. But only one of them is undefined when x is equal to 2. The other is undefined when x is equal to, actually, they're both undefined when x is equal to -2. All right, so we're good to go there. But then it's a question of, well, what's going on when x is equal to the +2? All right, because that's the oddball there. All right, because we know what's happening at x equals -2. I could show you. X equals -2. Make it dashed. That's a vertical asymptote. Right. So, and it's a vertical asymptote for both graphs, for this graph and for this graph. Right. No matter which one we're looking at. So this is a vertical asymptote. So for the other one, that x equals 2, it's like, well, what's happening at x equals 2? Well, if I go to x equals 2 on my first graph, you see it says undefined as a coordinate. But you also see, hopefully, an actual literal hole, like an open circle. Oh, you did a second ago. There it is. Add 2, it says undefined. It's not a vertical asymptote. It's actually a hole in the graph. It's a skipped point along this function. They also call it a removable discontinuity because when I look at the simplified form and I go to x equals 2, it's now a defined point. There's no hole there anymore. We were able to remove the hole by simplifying the function. But it's the original function that we care about. All right. So if we look very closely and carefully at 2, it does appear as though it's at, I mean, you go by the scale, this is half a unit. This looks like it's half of that half a unit up. I mean, if you're eyeballing it, you'd probably say, okay, half a half is a quarter. All right, but you're not sure. So what you do is you graph the simplified form because you know that one is actually going to fill in the hole. It says undefined for this one, but if I turn this one off and look at the simplified one, it'll tell me that the simplified one has a point at the y value of 0.25, which is the same location that this one has the hole at. All right, so there's a hole here at 0.25. It's filled in for this one, but it's the same location. So we can conclude now that there is a hole at 2, 0.25. All right. There's a slightly different way of handling that. I can show you real quick. Everything that we did so far is actually the same. The way of analyzing or evaluating it doesn't involve looking at the picture. It involves looking at the tables. So if I hit the little gear icon here and look at the tables for the first graph, you know, the original function graph, and then a table, you know, tap on, so hit that gear icon, hit that little table icon next to the graph, I'm sorry, the equation, you'll see that at -2, for the f of x function, it's undefined. All right. At -2, it's undefined for the original function, and it's undefined for the simplified function. Right? If it's undefined in both cases, then it's an asymptote. Right? So if simplifying the function doesn't get rid of the undefined, then it's a vertical asymptote. So we knew it was that way visually, but now we verify it by a table. Now, in the case of f of x, we see that there's also undefined at the x value of 2. But then when we go to the simplified function, at 2, it's not undefined anymore. There's a 0.25 there, right? So that's another way of handling it, because you know that the point must have been filled in by that 0.25. Right? So one more, and then I'll let you go. Let's do number 2. So factor, we have x plus 2, x plus 2 on the top, x plus 2 on the bottom. Right, this is undefined if x is equal to -2. So then you simplify, which means that you're going to cancel the denominator, in this case, with only one of the factors on the top, leaving you with just an x plus 2. That one is never undefined. All right, line, this is a line. Lines don't have asymptotes. Lines are asymptotes, if anything. They don't have asymptotes, right? So I would graph my original function. This one's g of x, x squared plus 4x plus 4 over x plus 2. And then I would plot y equals x plus 2. I don't need this. I'd look at these two separately and say, okay, well, this is my original. At -2, it's not a vertical asymptote. I would ask myself, is there a hole there? So I'd go to the x value of -2. I see that it's undefined. There's a hole. I would just need to know the y value that would fill in that hole. Now this you can get visually. You just look at it, it's right on the x-axis. So you could say that there is a hole at -2, 0. But let's say you're not sure. I know that I'm looking at this location when x is equal to -2. So turn this one off, go to the simplified, go to the x value of -2. Whatever the coordinates are at that location, that's the location of the hole. I'm going to put a star on number 3. Give that a shot. And just like the last page, we're not worried about creating the graph, because that's what Desmos is for. So I'm going to stop the recording.